Black holes are among the most intriguing and enigmatic objects in the universe. These mysterious regions of spacetime challenge our understanding of physics and the nature of the cosmos. The idea of black holes has captivated scientists, astronomers, and the public for decades, sparking both awe and fascination. But what exactly are black holes? How are they formed? What role do they play in the universe? In this report, we will explore the nature of black holes in detail, from their formation to their influence on the universe, and how scientists study them despite their elusive nature. What is a black hole? At its core, a black hole is an area in space where the gravitational pull is so intense that nothing, not even light, can escape. This phenomenon occurs because black holes have an incredibly high density packed into an extremely small volume. As a result, the curvature of spacetime around a black hole is extremely sharp. The defining feature of a black hole is its event horizon, which is the point of no return. Once something crosses this boundary, it is pulled inexorably toward the center, known as the singularity, from which it cannot escape. This concept of the event horizon and the singularity is what makes black holes so fascinating. The formation of black holes. Black holes are not objects that exist from the moment the universe began. They are created during the life cycle of certain stars, particularly those with much more mass than our Sun. 1. Stellar evolution and collapse. Most stars, including our Sun, undergo a life cycle where they burn fuel in their cores, releasing energy through nuclear fusion. When a star runs out of fuel, it can no longer maintain the balance between gravity, which pulls inward, and radiation pressure, which pushes outward. As a result, the star's core begins to collapse under its own weight. This collapse happens in stages. For smaller stars, this results in the formation of white dwarfs or neutron stars. But for very massive stars, the collapse continues further, creating a black hole. Supernova explosion. The collapse of a massive star's core is often accompanied by a violent explosion known as a supernova. This explosion ejects most of the star's outer layers into space, leaving behind a very dense core. If the remaining core's mass is above a certain threshold, typically more than 3 times the mass of the Sun, the core will collapse further into a black hole. The structure of a black hole. Understanding the structure of a black hole requires a brief dive into the concepts of general relativity, Einstein's theory that describes the behavior of gravity. 1. Event horizon. The event horizon marks the boundary beyond which no information, matter, or light can escape. Once something crosses this boundary, it is effectively lost to the universe, with more massive black holes having larger event horizons. The event horizon's size depends on the black hole's mass. 2. Singularity. At the very center of the black hole lies the singularity, a point where the gravitational forces become infinitely strong and spacetime curves infinitely. The laws of physics, as we currently understand them, break down at this point. The singularity represents the ultimate collapse of matter and energy into an infinitely small space, accretion disk. In many cases, black holes are surrounded by a rotating disk of matter known as the accretion disk. As material from a nearby star or gas cloud falls toward the black hole, it forms a hot, luminous disk as it spirals in. The friction in the accretion disk causes it to emit intense radiation, making these black holes detectable with telescopes. Types of black holes. Black holes come in different sizes and types, determined by their mass and the way they form. Stellar mass black holes. These are formed when a star with sufficient mass undergoes a supernova and collapses into a black hole. Stellar mass black holes typically range from about 3 to 10 times the mass of the Sun. Supermassive black holes. These black holes are found at the centers of most large galaxies, including our own Milky Way. They can have masses ranging from millions to billions of times the mass of the Sun. It is still not entirely clear how supermassive black holes form, but they play a crucial role in the dynamics of galaxies. 3. Intermediate mass black holes. These are a theoretical class of black holes that fall in between stellar mass and supermassive black holes, with masses ranging from hundreds to thousands of solar masses. They are harder to detect, but there is growing evidence that they may exist in certain star clusters. 4. Primordial black holes. These hypothetical black holes could have formed in the very early universe. Just after the Big Bang, they would have much smaller masses and might have been created due to high density fluctuations in the early universe. How black holes influence the universe. Despite their invisible nature, black holes play a significant role in shaping the universe and its structures. 1. Galaxy formation and evolution. Supermassive black holes are believed to be at the heart of most galaxies. Their immense gravitational pull can influence the movement of stars and gas within the galaxy. Some theories suggest that the formation and growth of supermassive themselves black holes may have been closely tied to the development of galaxies. 2. Gravitational waves. When two black holes merge, they produce ripples in spacetime known as gravitational waves. These waves were first detected in 2015 by the LIGO Observatory, confirming a key prediction of Einstein's general theory of relativity. Gravitational waves provide a new way to study black holes and other cosmic phenomena. 3. Time dilation. Due to the extreme gravity near a black hole, time itself is distorted. Clocks near the event horizon tick slower relative to those farther away. This effect, known as gravitational time dilation, has been confirmed through experiments with satellites and is a fascinating consequence of Einstein's theory. Detecting black holes. Since black holes cannot be observed directly because no light can escape, scientists rely on indirect methods to detect them and study their properties. 1. X-ray emissions. When matter falls into a black hole, it often forms an accretion disk that heats up to extreme temperatures, emitting X-rays. Telescopes that detect X-rays, such as the Chandra X-ray Observatory, can help astronomers find black holes by observing these high-energy emissions. 2. Gravitational lensing. Black holes can also be detected using gravitational lensing. When a black hole passes in front of a distant star or galaxy, it bends the light around it, creating a distorted image. This phenomenon is a direct result of the extreme warping of spacetime near the black hole. 3. Gravitational waves. As mentioned earlier, the detection of gravitational waves from black hole mergers provides another method for studying these objects. These waves carry information about the mass and spin of the black holes involved in the merger. The future of black hole research. While much has been learned about black holes, they still remain mysterious in many ways. Scientists continue to probe the boundaries of black holes, testing the limits of our understanding of physics. New technologies and advancements in telescopes, like the Event Horizon Telescope, which captured the first image of a black hole's event horizon, promise to reveal even more about these enigmatic objects. In conclusion, black holes are among the most extraordinary phenomena in the universe, from their formation during the collapse of massive stars to their role in galaxy evolution. Black holes challenge our understanding of the cosmos and the laws of physics. As science advances, we continue to uncover more about their structure, their behavior, and their significance. Black holes are not just objects of curiosity. They are a key to understanding the fundamental workings of the universe itself. For those interested in learning more, there are numerous resources, both online and in libraries, where you can explore the latest discoveries and theories. You can also engage with astronomers and scientists who continue to push the frontiers of knowledge on black holes and other cosmic wonders.